Hello, hello. Hello, everyone. Hope everyone is enjoying the lunch. As you're eating the food, please feel free to stop by and take a look at the spotlight programs we have. Today I'm continuing the spotlight talks from yesterday. Yesterday we had 6 projects describe and introduce their projects. Today we're going to have 5 more. Before we get started, I want to introduce a little bit about the spotlight program. Basically, it's a project to highlight great open source AI projects, AI papers, or community efforts that are going on around the world. And it's to help provide visibility to these projects and encourage others to know about them and also help participate in them. And also it's to encourage collaboration among these projects and encourage a community type of growth for these projects. We encourage everybody to participate. The website is spotlight.gosim.org. If you are a project participant or owner, you can definitely apply for your own projects. Or if you're just a user, you can also nominate other projects to be a Spotlight finalist. And this is the first Spotlight program, but definitely not the last. We have currently the AI Spotlight. Next week at the Rust Week event, we're also going to have the Rust Spotlight finalists. And later on this year, we're planning another Spotlight program for other new projects. So check out the website and think of any projects that deserve the nomination. Please submit the information. Thank you. And then this is just another plug for the next GOSIM event. It's going to happen in September in Hangzhou, China, which is now almost the de facto capital of AI in China, where all the companies doing AI are located. So there will be a big event this year in September. We're going to open up the call for paper, call for proposals very soon. The website is already up, so you can check the information. It'll be updated continuously. And if you're interested in any of the programs, we also have newsletter submission on our website. So just enter your email, and then you'll receive letters, emails, updates on new events that are going to happen. We don't spam, we don't sell the list to anybody. So, in fact, actually, I don't think we've sent any email out to that newsletter yet. So it's very low frequency sending. So please subscribe. So today we're going to have the talks from Code Carbon, Llama Factory, MOFA, Little Rug, and the Think Small, Act Big AI paper. So without further ado, I'm going to pass the mic to Code Carbon. Benoit? Yes. Here you go.
Thank you for having us. Thank you. Thanks. So I will talk about Code Carbon. It's an open source project that you could use to measure carbon footprint of your server, especially AIs. And so I will talk, I present who am I and what is Code Carbon, how it works, and how to use it, and what you can do with it. So I'm a data scientist at the French Parliament, but I'm mostly here for being the president and the main contributor of Code Carbon as a volunteer. And so Code Carbon is a Python package. It's open source, and we are open to contribution, so don't hesitate to contribute or open issue on GitHub. And Code Carbon was born in AI Live in 2020. It was an idea of Joshua Benjo, who worked on it in Mila in Quebec. And it's an old vision. At this time, the carbon footprint of AI was mostly on training, but right now it's also critical today because inference is using more and more power. For example, the next NVIDIA rack, maybe you know that it's just a rack of this size. could use as much power as 600 microwave plug for every hours in 7 weeks all the week. So it's beginning to be really critical, and we expect the power consumption of data center to just double in a few years. So Code Carbon is here to give you an idea of what's your carbon footprint using your AI project, for example, and to give you comparison points. And we do real-time measurements. Code Carbon communicate with the hardware. It's not an estimation for our project, and we measure the electricity consumption of the hardware. So we support NVIDIA GPU, we support many metrics for CPU, and also RAM consumption, and we multiply the energy consumption by the carbon intensity of electricity based on the country where you run your project. So for example, if you run your project in France or in Poland, you don't have the same amount of carbon footprint for the same power. There is a very huge difference. So we have Code Carbon could run offline without internet connection, but use a static database of the carbon emission of electricity, or you could use it online with Electricity Map API to have real-time estimation of your carbon footprint. And it's quite easy to install. You just have to do a pip install, and you could, if you want to use the API, you could use Code Carbon config and Code Carbon monitor, and you will have here the tracking will be linked and give you insight of what the hardware has been recognized by Code Carbon and how it works. And it will monitor behind your running code. It's a real lightweight package because it only runs a few seconds. It's scheduling to just check regularly the amount of carbon footprint. And you could also import it in your Python code and monitor your project. And you could see it's really only 2 lines of code to integrate Code Carbon in your project. So it's really simple. And we have an architecture that could be a bit complicated. You could use Code Carbon locally and just being offline, or you could use our API. The API is also free to use, thanks to Clever Cloud. And the API allows you to gather the data and to do aggregation between your many runs. And we also have an online dashboard where you could log in to see your emissions. And we offer a bit of comparison to give you, for example, insight of what it represents in terms of kilometers of car or household consumption or watching TV. So it gives you some insight of what it means, the metrics we get. And you could create some experiment. You could choose what experiment to see, or you could see the whole consumption. And you could also click on some run and see the real-time data that has been gathered. And so what you could do to reduce your carbon footprint, the first thing you could do is to keep your hardware longer. Maybe it will use more energy because it's old hardware, but the whole carbon footprint will be lower because building new hardware have a cost in terms of carbon footprint. And you could also, if you are really using AI every day, you could also choose the model of AI you are using to choose model that is really adapt to your needs and not using always a big model for everything. You could fine-tune your model, you could choose a location of where you are running your code, like we previously did. In France, we have very low emission electricity, and some country it's really different. So you could choose our location. You could also use optimization tools like Zeus. It's a tool that reduces the GPU frequency to have the same result of training, but with lower energy consumption. And yes, you could also choose your location. Sorry, you did 2 times. And thank you for listening. Maybe you have some questions for me. And we thanks Mozilla for supporting us. Last year we have a grant from Mozilla to develop some security on the API. And we are also part of Data for Good France, and we are supported by Clever Cloud that powers the API and the dashboard to allow everybody to use it freely. So yeah, thank you. I don't know if you have some questions about Cloud.
Hey, my name is Olga. I can use this tool for AI projects, but if I want to measure the impact of third-party LLMs, for example, can I use this tool as well?
You mean LLM that you call behind an API like OpenAI or things like that? So no, Carbon don't do that. But there is a French project that is called Ecologist, who monitor the API codes and have a database of what it costs for a given token number. So yeah, it's a tool that could be used. Yeah, I could spell it for you. It's Ecologist. Any other questions? No. So thank you.
All right, thank you. Okay, next up we have the Claudio.
Hello everyone, I'm Sao Liu. This work is done, I'm in an internship at Shanghai Lab, which is about think and act. In the later this year, I will join the Beijing Academy of Artificial Intelligence. Okay. As we know, robot manipulation often suffer scale scaling issues. We want to solve this part through a primitive prompt. Okay. First, in this work, we propose a primitive prompt learning method. First, I want to explain what is the primitive. Primitive is a subset of the whole demonstrations. We want to use some small actions or multi-action sequence to replace the single action to simplify the non-horizon task. And besides this, we must achieve the lifelong robot manipulation. So we import reusable and extensive primitive prompts. Okay. In this way, we present the motion-aware prompt while text and flow query, which is designed to represent a shorter primitive between the scales, and we can efficiently transfer the scales to the new task or new scales. Okay. Finally, we construct a very large scale data sets, which is not similar with the previous data set. We divide a robot data set into scale or primitive data sets to achieve a more efficient scale transfer. We can see the primitive is the division of basic tasks. For example, for a logger cleanup task, we can divide into open journal, grasp mark, and pick marks as 3 subtasks. And for each subtask, we can continuously divide into some primitives like left and turn right. Okay. The minimal action unit is the primitive we proposed. Okay, this is the whole view of our PPL. First, we would inject RGB images and language instructions, which is a common setting. But we also inject a new model, is optimal flow. Why? The optimal flow can efficiently capture the moving information. This is the most important we think to transfer the knowledge, but not just from the language levels. Okay, and how to reuse our scales? We think optimal flows may show the most important transfer of common knowledges. So we in the first training stage, we pre-train much actually about 14 primitives in our large scale data sets, and then we can weight these primitives and add some initialized promos to achieve and add these things to get the final new scale primitive prompts. And then we inject these things into the common diffusion policy head or padding like flow matching method. This is okay. Okay, in this way is the motion aware promoting. It's exploring the language and the motion to get which part of the tasker process, and the way is very easy and efficient. We can just use the MLP to inject all information in this part. In the left, we can see the optimal flow is focused on the robot itself, but not and the moving objects. Okay, this is the impact of our MAP on the problem weights. For just text only, we found different scale, different tasks cannot efficiently distinguish the task one the tasker grasp and tasker place. But our text and optimal flows, we can easily distinguish which part the robot are going. Okay, for the texture and the flow information fusion, we use a very simple and efficient weight sum promotes to get the efficient to gain greater performance. we can see the alpha M is the concise similarity of attention query and the prevails prompt K. It can evaluate or measure the similarity of our current task and the previous task primitives. Okay. These two parts is our design for implement. We have to see our scale data set is the most largest scale level data set. It including the simulation and real world data. The simulation is constructed upon liberal mimicking and some area bench data assessing. For real world, we connect about 8 tasks and about 4,000 actions for each task. Therefore, these two both constrain our scale data set and through two-stage training to extract corresponding primitives and the new tasker primitives. I catch some important result that I think the most interesting result is this one. The ablation study, we found our method can filter different or various lighting conditions. We can say about warm light, half warm and half cold light, and dark light for setting. Our method achieve great performance compared with the method with text-only prompts. But we also can see the text-only or flow and text method is harder to distinguish the cold light conditionals. Therefore, we will explore our method in the future work to generalize to more general lighting conditionals. But I think this work can give us some insights. Okay, the right one is the detailed ablation studies about the primitive numbers and the primitive baseline and its performance comparison between the LoRa and the mixture of experts. Okay, that's all. For more details, welcome to our booth. Have a nice talk. We are in the Beijing Academic of AI Artificial BAI. Okay, do you have any questions? Please.
Yes, hello. I have a question. How does the diversity of the skill data set influence the generation capabilities of BBL across unseen manipulation tasks?
I see. It's page. This page. Is this page or? Okay.
It was like this question.
Oh, I see. Is that our data set between compared with previous data set, we divide the whole demonstrations into some sub-demonstrations. This can more general because pick a place or pick and place may be contained by 4 small actions like turn left or turn right or turn off some actions. But pick just this language cannot including this action information. But this action may be more maybe constrain more common action knowledges. Thank you. Any questions? Okay.
Right. Yeah. Okay, thank you. Next one up will be the video rag, and the speaker for that will be Rishi. So welcome up.
Okay, hello everyone. Today I will present to you our work, VideoRag. This work aims at improve the performance of visually rich document in a RAG system. So I will first give a brief introduction of our work, including the VideoSeek dataset and the VideoRag framework. Then we will take a detailed look into our framework, including the multimodal hybrid retrieval and the multi-agent generation. And finally, we will have a look at the experimental results of our VideoRag framework on the VideoSeek dataset. And last, we will talk about our future work. So first, our work aims at improve the performance on visually rich document. So traditional RAG methods face challenges in understanding visually rich document. In this sentence, we can find two key elements. One is the traditional RAG methods, and the second is the visually rich document. So I will explain it step by step. First, what is the traditional RAG methods? It is proposed by OpenAI. It is used to add external knowledge to large language models. For example, if I had some knowledge that is stored in some document, we will first transform the document, the knowledge in the document into text. Then we will split the text into small chunks and using an embedding model to transfer these chunks into vector. And then we can use a vector database to store all these informations. Then when we want to use these informations, we can transform the query of the client into a vector and search it in the vector database. And we can get the most relevant information from our database by using the similarity between vectors. In the OpenAI's best practice, it uses the top 10 chunks, and it adds these chunks into prompt to improve the final performance of the large language models. Okay, that's the traditional RAG method. And what is visually rich document? We can say that I give an example here. It is also a page from a document in the real industrial scenarios. If I pose a question, what is the competition media in East? So how can we answer this question? We have to first find out the color of competition media. That is the purple. Then we know that the purple is in this column. Then we have to find out where is the East. Okay, East is here. So we can find that the answer is 6%. So imagine that if we use the traditional RAG, how can we deal with that? We have to first transform this document into text. But how can we transform these colors? No, if we use the OCR-based methods, we will lose all these colors. So we cannot find out what is the color standby competition medias. So we cannot respond these questions. So that's the difficulty and the challenge the traditional RAG methods face. So we propose our work, VidoRAG, to tackle these challenges. So to deal with these problems, we have to build a benchmark to evaluating the performance of RAG in these scenarios. So we try to reuse the traditional VQA dataset, but we find that in the traditional VQA dataset, it is not suitable for RAG system. For example, if we have a query, we find out that in the traditional VQA dataset, we can have many answers refer to this question. It is not suitable for a RAG system. So we introduce a VidoSeq dataset to benchmark this task, and we propose a VidoRAG framework to bridge the gap. First, our VidoSeq dataset is released in the GitHub, and all of you can use that. It is designed for the visually rich document, and it contains 1,200 questions across a wide area of domain. And each query has a unique answer. It's very important in a RAG system to have the unique answer. And we have diverse content types like text, chart, table, and layout. And we have multiple reasoning types like single hop and multi-hop. And this is a pipeline we built this dataset, including data collection, query creation, and we manually reviewed the answer, and we finally used some automatic methods to refine the answers. So we have a high quality. So this dataset has a high quality, and I recommend you to use this dataset if you have the same problems in your situation. And now we have the benchmark. We can evaluate our RAG systems. And after the evaluating, we find that the traditional RAG systems has two main drawbacks in this situation. One is the inefficient retrieval performance. The second is the insufficient reasoning capabilities during the generations. So we propose two methods. One is for retrieval and one is for generating. First, for the retrieval, we can see that this visually rich document, it contains many visually elements. So if we convert it only to text, it will lose many information. So in our work, we also use the image, the raw image, and we use a multimodal embedding to embed this image. So in the retrieval phase, we have two pipelines of retrieval. One is using text embedding to retrieval by text information. The second is to use multimodal embedding to retrieval from document images. We take the page, we take the whole page as images. Yeah, so once we have the two pipeline results, we have to merge that. Yeah, so we propose sophisticated strategies to combine them together. If you are interested, you can see our papers. It is also on archive. Yeah. After that, in the generation steps, we find that if we use a visually language model in the RAG generation stage, we have another problem that doesn't occur in traditional RAG systems that use only language models. That is the visual language model cannot deal with too many images. For example, since nowadays the language models have larger and larger input lengths, so the language model can take, for example, 100 pages as input. But if we use visual language models, we can't take 100 images as the input of a visual language model. So we have to compress these images. For example, we compress 9 images into one. Yeah, that's so we can give more information to the large language, to the visual language models. But if we compress the image, we can lose some information. For example, some section of the image is blurred. The model cannot see it clearly. Yeah, that's why we propose multi-agent generation with iterative reasoning. The iterative stands that if the model think some portion of the image, since we compress them, some portion of the image is not clear, but it is very important to answer the questions. It can zoom in this section and examine it detailedly and get the answer, and then zoom out and see if there are other sections important, and it can zoom in and zoom out. After the iterative process between seeker agent and inspector agent, once the inspector agent think it has enough information, it can generate a draft answer, and finally an answer agent can generate the final answer. Yeah. I think it's very important for zoom in, zoom out action. Like in these days, other companies have also released the visual language model that can turn or zoom in, zoom out some images. I think it's a very important action in the visual language model. Okay. So let's take a look at the final results. We find that we use accuracy and recall as our evaluation metrics, and we compare our video reg to text reg and visual reg, and the results shows that our video reg outperforms the existing methods by around 10% improvement. Yeah, that's a great improvement. And we can see that by using the retrieval strategies, we can achieve the comparable performance by reducing the candidate pages from 10 to 6. Yeah. And our strategies, since it is an iterative strategy, so it takes more time. It takes around 2 times slower than traditional reg. So, but it improves the overall performance. So our future work will focus on optimizing the framework's efficiency while maintaining the high accuracy. And we are also doing some reinforcement learning trial on this process. And I think the point is that the video reg demonstrates that there are significant improvements in visually rich document if we use a multimodal embedding and visually rich and visual language model in this situation. Yeah, and that's all for my presentation. Thank you. Any questions? Okay.
I'm actually curious about the image embedding that you create. Like, how do you create embeddings for the image, for the images? And also, when you're doing similarity search, similarity rank, like, do you rank the images from the the text or from what?
We use multimodal embeddings, but in our work we don't train multimodal embeddings. We use the model released by other people like VisRag and Copilot and CoQ1. Yeah, and we find that the CoQ1 has the best performance from the time of this paper. Yeah. And we doesn't do re-ranking process. And I think if you add a re-ranking process after the retrieval by using a visual language model, it will have better performance. Yeah. Okay. Okay.
This method can use in digital transformation. I think the application domain for electronic image, you can transform the component, find easily the component and transform it in digital document. Not only text, but text have graphical document.
Yes, since it uses multimodal embedding and the visual language model, it can apply to a wide range of applications. Yes, that's why I'm here to introduce you this work so that you can use in your scenario. Yeah, and our work is released on GitHub, including the code and the dataset, and welcome to start our work. Yeah. Okay.
Because recently I have heard about the SAN project. I just wonder if you test about the cost of SAN project. For example, test for the PhD, PDF for the SAN task. Have you tested about the cost?
Yeah, we will test about the time consumed by this process. Yeah, it costs 2 times. Okay, the inference. Okay. No, we will not count that because it's more and more cheap. It's cheaper and cheaper nowadays. The cost of models. Yeah. Okay.
Thank you. All right, thank you so much. Next up is Yahweh. If you had a chance, you did. He had a great talk yesterday in the infra track, and now he's going to speak on another project, the Llama Factory. So welcome on stage.
Hello everyone, I'm Yao Zheng, the founder of Llama Factory. I'm very glad to be here to the spotlight session of GOSIM Paris event. First, let's look at this video. This video shows how to fine-tune large language models with our web UI in 10 minutes. In this video, we select the quant model and choose the dataset to fine-tune. And we can configure the preview the dataset in the web page and configure the LoRa parameters. Yeah. After that, we can launch in the model training by choosing the save path and then click the start button. During the training process, we can observe the training progress bar and the training loss curve. after 5 minutes, we can get train the LoRa adapter. We choose the LoRa adapter and enter the chat tab to load the fine-tuned model. Then we can see the fine-tuned model, the chatbot of fine-tuned model. We can ask some questions. It is the question, the answer is is aligned with our dataset. Yeah, they can answer the multiple questions in the tab. We can choose the export tab to merge the LoRa adapter to the base model, and also we can upload to the Hugging Face Hub for sharing the open source model. Yeah, the exported model checkpoint can be used by VLAM or Llama for inference or downstream use. So the main advantage of Llama Factory is that it supports a very wide range of models. It includes hundreds of popular models. You can select the model for fine-tuning according to different scenarios and requirements. And due to our modular design, we can support the model as soon as the model is released. Models we are supported on day 0, including Quan 3, Quan 2.5 Wheel, and GMAR 3. For the latest Llama 4 model, we achieved adaptation on day 1, and Llama Factory is the first framework to support the Llama 4 model. To facilitate users in complete model training in different devices, we have integrated many parameter-efficient fine-tuning methods, including low-rank adapter, low-rank optimizer, LoRa, Apollo, and various improved algorithms based on LoRa. Yeah. Therefore, Llama Factory can achieve pre-training, supervised fine-tuning, RLHF, DPO, and other training methods on consumer devices. Memory management during large language model training is very challenging problem. Taking Llama model with 8 billion parameters as an example, during the training process, it requires 32 gigabytes of GPU memory to store the weights, and 96 gigabytes to store the optimizer states and gradients, and over 100 gigabytes to store the network activation. So in total, the GPU memory required for training exceeds 200 gigabytes. Therefore, Llama Factory provides different automation strategies for single GPU and multi-GPUs scenarios. For the model weights, we can use quantization methods such as GPDQ and AWQ to represent them with low precision float point numbers. And also we can adopt the deep speed 0-3 strategies for weight charging. For the optimizer states and gradients, we can use low-rank methods such as LoRa to reduce the GPU memory footprint. Regarding the activation, we have flash function and gradient checkpointing enabled by default. These techniques reduce the peak GPU memory usage through chunking and recomputation. Soon we will also integrate more methods like Ulysses and real-time to achieve sequence parallelism. Finally, we can even use CPU offloading to relieve the GPU memory load. In addition, we support the use of efficient operators in like kernel and on-slots to further accelerate model training. We have replaced the original naive implementations through monkey patching. Combined with on-slots, asynchronous gradient checkpointing strategy, the training performance has been further improved. Through our experiments, if we increase the length of input sequences, the improvement of MFU model flows utilization brought by the efficient kernels become more significant. Meanwhile, since their kernels reduce the peak memory usage, we can observe that the maximum sequence length for full fine-tuning and for full fine-tuning has increased from 4,000 to 32,000, and the maximum sequence length for lower fine-tuning have further increased to 64,000. Through the series of efforts, Llama Factory provides a one-stop training and inference experience. Users can only need to focus on the construction of data, and Llama Factory will implement the remaining pipelines. Specifically, Llama Factory has implemented the model training based on PyTorch and DeepSpeed frameworks, as well as the model inference based on VLab and SGLab. After the model is fine-tuned, it can provide API services, which greatly saves the time for manually building the pipelines. Another characteristic of Llama Factory is that it provides multimodal capabilities. Currently, we already support data in 3 modalities: image, video, and audio. These modality capabilities come from the previous model themselves. For example, we can use Llama 4 and Gemma 3 for image understanding, Quen 2.5 will for video understanding, and Quen 2 audio for audio understanding. We further support a mixed modality. Both Quen 2.5 or Mini and Mini CPMO can achieve full modality training and inference within Llama Factory. Next, let's look at the video to see how to perform interactive inference in Llama Factory. First, we can take a photo and we input questions to the model. As you can see, the model can answer the question based on our image. Additionally, we can use the microphone to record the audio and have a voice conversation with the model. The model can answer the question according to our input audio. In addition to model fine-tuning, Llama Factory also provides data solutions. We have published a blog post on synthetic data construction with the Easy Dataset open source framework. Easy Dataset is a desktop application with a visual interface that can synthesize data samples for model fine-tuning. Developers who are interested can scan the QR code on the right to read in the full blog post. Llama Factory has benefited from the open source community and is also actively contributed to it. Our GitHub project has received over 48,000 stars and has more than 100 contributors. On the Hugging Hub, there are over 6,000 models trained using Llama Factory. During the development of our framework, we also submit dozens of bug fixes to the Transformers framework, which are recognized by the maintainers. Llama Factory is still in rapid development. There are several new features we are working on. We have collaborated with the engineers from any scale to complete the integration of Ray, allowing users to experience the power scaling capabilities of the Ray trainer in Llama Factory. We will also support sequence parallels very soon, and hardware adaptation for Intel HPO is the most completed. You are welcome to keep an eye on our process. That is my sharing. Thank you all. Yeah, any questions?
Thank you so much, Alvin. Okay, so we're coming up for the last speaker of today for our spotlights. Yeah, and so someone here will talk about the modified everything agent, and we will do some live demo, I think, as well. So just give it a minute.
还有一个，这哥们儿讲完，没那么多了，中午一讲不了这个，刚才说了嘛，老板还讲这个了，中午这小会儿还讲了，讲不了那么多人。这个是刚课嘛，刚开始，无所谓的，就是他讲完就完事儿了。
Thank you.
这么多啊
It's not mirroring.
真的
It's not mirroring.
天哪，这么多！
Sorry about it. We have some technical difficulty.
这儿停哪儿？
Let's go back with your computer. You have a machine. You don't? Okay.
啊？不知道啊，这个我怕它随时开始。啊？这后期好剪嘛，要不后期它就两边不好对。后期它对齐4后剩下的就都好弄。后期就是最怕的就是这个。 这边关那边开，那边关那边开，往后退一层，而且咱们还没有时间码，就是说后期的这个成本。
Hello everyone, sorry for the technical difficulty. So I want to introduce our open source project called MOFA. Basically it's another development framework for agent. And I want to introduce the idea behind it. We actually have this mindset called everything agent. So I will just go through maybe from very conceptual level to explain what is the idea behind. Then I will give a few examples. So we actually think everything's agent. It's like agent is just a new fancy name for the programs. I think nowadays people think like agent is different from the traditional programs. That's nowadays people think this way. But in our mind, we think like the LLM-driven agents and the traditional programs, we kind of think they are the same. We want them to work together. We want to connect the fancy LLM-driven agent with the traditional programs too. So we want to solve the problem, like how to connect them. The basic idea is like to through the encapsulation method. So it's actually very simple. If you have your own program or API or any agent, you have your own code. We kind of put wrappers between them. So we try to figure out what kind of configuration you need, like the secret keys or some other configurations of your program. We try to manage it we put those configuration in the .env.secret file, and we kind of have the agent have our mechanism to take care of the input. Put the so when people send the queries to agent, the agent will be able to get it and transfer to the format that your program needs. Then your program have the output. The output will be sent to our output handle function. Then we get we can turn your program into an agent. That's the basic idea. So we actually have this. We build an agent that do this thing for us. So basically, if you have the RESTful API document, you want to turn the API into an agent, or you have some Python programs, you want to turn the Python program into agent, or you can the project is in the GitHub repo. You want to turn the program in the GitHub into agent. Or you don't have anything, you have some prompt. Then we developed we call it intelligent agent incorporation agent to be able to process those input. Then we first figure out what the configuration you need. We then figure out what kind of dependency you need. We figure out that, then we generate the code to make everything MOFA agent. When you're able to do it, then all those pieces of software you can have like a unified interface. You can connect them very easily. By the way, this is not fully done yet. We kind of solved the API problem, and those things are actually in progress. We're not ready. Okay. The second thing is like, okay, we have agents. We need to get them together, and we want to be able to make everything composable. So by composable, we mean like we want the agent to connect to each other to be able to do something, but we can also easily decompose them. We want those agents to be loosely coupled rather than very tightly coupled. Okay, so when you're able to do this, then you can basically reuse all the individual agents, or you can just you have different people work on the different agents. Then later you compose them together again. Then you have a stronger agent. Or you can use your agent in different combination to do different job. So unlike most of the other agent orchestration framework, we kind of not using the workflow for the orchestration. We use data flow. So the idea is like we think the workflow is still a little bit too complicated. So you have like the logic at the flow level, right? You have like the task, the condition to take care. But in the data flow, you only have the operations. And the data is, when the operation is done, the data coming from one block to the other. So it's much simpler. It's actually more composable. It's actually more, compared to the workflow, it's like the more loosely coupled kind of flow. So we think this is it's more like a data-driven, and this is like a workflow. You need to take care of the states. It's like more about the control. This is more about the flow of data. I don't want to get into the details. I can say a lot, but I don't want to get into details. I just want to say like this is a composable flow, and that one probably is more like a more tightly coupled compound flow. Okay, so we pick this. Another significant difference of our framework is like we kind of sit on the distributed computing framework called Dora. Many of you probably already know Dora. They are also here. But basically, what Dora do is like they help us to manage the computations. You can have like different nodes. You can have different computers. And you can put MoFA agent in 1 in A, 2 in B, 3 in say 4 and 5 in D. So basically, you have we can have like the multiple agents run on multiple computers, multiple computing resources. From our perspective, we think Dora provided our computing kind of capability. The computing is composable, and we have this MoFA agents are like application level is compositional, so we call it composition AI. So we have a few examples. For example, we encapsulate the mem0. So mem0 become our memory service provider. We encapsulate the long chain RAG agent. It become our RAG service component. It's just those are just examples. You don't have to use them as your applications agent service, core services. Based on your need, you can plug in different like those memory planning, RAG, those kind of services. Whatever is fits to your need. Another example is like we incorporate the file crawl. So immediately you have this crawling tool as a MoFA agent, and you can compose those tools together to do your job. Also, like if you have like separate API, you can intelligently incorporate with our framework. So API become agent. the DeepSeek or ChatGPT, those are APIs. Essentially, those are APIs. You can incorporate them in. Then you become you can use a different LLM inference in your application. So LLM becomes agent. As I said, like there is like a traditional programs like you want to send an email. There is already like a lot of the tools. So you don't need a large language model to program such kind of tools. Then we can incorporate them. They become agent too. So everything is agent. And with those agents, we can do different things. For example, we actually did a data flow for like a GOSIM. GOSIM, every speakers, for every speakers they want to learn the background better. So we actually have this 4 agents kind of data flow. We have a planning agent. When you go to you want to get the information of the speaker from their home page, we use crawler, right? We use crawler. If you want to, we already have some information of the speaker, so sometimes we use RAG, right? So quickly we can build such kind of data flow. And actually, I'm not sure if I can show you at the end of the talk. Just yesterday, a few of our community developers they build workflows to generate a video. Probably I can show you. So we can do a lot of things with the encapsulation of different programs and with the data flow to enable composition. So we think like the composition is the way to enable ordinary people to do extraordinary things. So you can, for each of us, our resource is very limited. So we can focus on one component, and later we can compose everybody's work together. So hopefully it will make the AI more sustainable. So that's actually the fundamental idea behind our work. And we think composition is one way of very fundamental way of integration. You have composition in mathematics. You have composition in biology. You have composition concept in physics everywhere. This is very basic. So hopefully, this if we focus on make the basic method working, we will be sustainable. So that's the idea behind. So kind of a recap. We actually try to encapsulate traditional program, RESTful APIs, LLM, and third-party agents, and utilize the DORA data flow to make them composable. With this mechanism, we can build a deep search agent, a visualization agent, or any other applications you want to build. And we make for the encapsulation, we actually use some LLM-driven method to achieve it easily. And we are also building the interface, because right now everything is like CLI. It's kind of boring. So we are making it try to build a nicer development environment for the people, for our developers. And we are trying to also build our communities. Yeah, it's basically my talk, and I don't know if this video will work. So we are actually at the back end, right? Sorry. And we have a brother and sister kind of project called Molly, and they take care of the front end. Yeah, I cannot. Sorry, I cannot make the video working. Can you make this? Yeah. Oh, that's okay. That's okay. So this is what we our community developer built yesterday. So they built like a few agents for a few agents like mobile agents, and they kind of create this video and concatenate them together, add those captions. And actually, the story is also generated by their agent, creative idea agent. So basically, they are trying to automate all the video generation kind of capabilities with mobile agents. Because if you use like any other tools, you always have the, for example, if you use iMovie, then you don't have like those animation capability. If you use some other tool, then you don't have like concatenation capability. So for those developers, they just make every tool available and make it a mobile agent. And as they need, they just connect them together, then become a more automated workflow. I'm sorry, data flow, right? So bear with us about the look and feel because it's generated by engineers, okay? But hopefully this tell the story, and you should be able to hear the music. But sorry about it. Another one is, as I said, like. So it's a little bit fuzzy, but this is basically Molly. This is a front end, and on the back end, we already use the CLI to fire up a deep search, a mobile deep search application, and. So basically, with mobile data flow, we have a planning agent, we have this search agent, we have the result analytic agent. We just simply connect them together, and we have this Molly interface to just have this deep search kind of capability achieved. We can, of course. We can, improve the planning. We can always improve the data analytic capability. We can always improve the summary kind of capability. So make this better. So just want to show the idea behind it.